The universe is a vast and mysterious place filled with countless wonders and phenomena that stretch beyond our wildest imaginations. It is filled with wonders beyond our imagination, from the smallest particles to the largest galaxies. Among these spectacular phenomena are supernovae, the explosive deaths of stars, which are both awe-inspiring and terrifying. These cosmic fireworks are some of the most powerful events ever observed, releasing energy on a scale that is almost incomprehensible. But could one of these stellar explosions pose a threat to life on Earth? The possibility, while remote, is a topic of great interest and concern among scientists. The sheer power of a supernova is difficult to comprehend, as it can outshine entire galaxies for a brief period. In a matter of seconds, a star can release more energy than our sun will emit in its entire lifetime, a truly staggering amount of power. This tremendous energy is released in the form of light, radiation, and shock waves that travel outward at incredible speeds, affecting everything in their path. The aftermath of a supernova can leave behind beautiful and intricate nebulas, remnants of the star's final moments, which continue to fascinate astronomers. But these stunning displays of cosmic power also raise concerns about the potential dangers they pose. Could a supernova happening close enough to our solar system have catastrophic consequences for our planet? The radiation and shock waves could potentially disrupt the delicate balance of life on Earth. The answer, like the universe itself, is complex and requires us to delve deeper into the nature of these stellar explosions, understanding their mechanics and the likelihood of such an event occurring near us. Stars, like our own sun, are not eternal. They are born, they live, and eventually they die. They have a lifespan, albeit one far longer than we can easily fathom. Some stars live for millions of years, while others can shine for billions. A star's life is a delicate balance between gravity, which pulls its material inward, and the outward pressure from nuclear fusion happening in its core. This fusion process converts hydrogen into helium, releasing immense energy. For most of a star's life, these forces are in equilibrium, allowing it to shine brightly for billions of years. This stable phase is known as the main sequence. However, this balance cannot last forever. As the star exhausts its hydrogen fuel, it begins to burn heavier elements. Eventually, a star will run out of fuel for nuclear fusion in its core. When the core's fuel is depleted, the star can no longer support itself against gravity. When this happens, gravity takes over, causing the star's core to collapse in on itself. This collapse is a dramatic and violent event. This collapse happens incredibly quickly, reaching speeds of up to 70,000 kilometers per second. The rapid implosion generates an enormous amount of energy. The core collapse triggers a shock wave that travels outward through the star's layers. This shock wave is powerful enough to rip the star apart. This shock wave is what we observe as a supernova, the brilliant explosion marking the end of a star's life. The light from a supernova can outshine an entire galaxy for a short period. The material ejected from the star during a supernova is flung out into space at incredible speeds, enriching the interstellar medium with heavy elements. These elements include iron, gold, and uranium. These elements, forged in the heart of dying stars, are essential for the formation of planets and even life itself. Without supernovae, the universe would lack the building blocks necessary for complex chemistry and biology. The destructive potential of a supernova is undeniable. These cosmic explosions release an immense amount of energy, capable of outshining entire galaxies for a short period. But just how close would one need to be to pose a threat to life on Earth? The distance is crucial in determining the level of danger. The answer depends on the type of supernova and the amount of harmful radiation it releases. Some supernovae are more powerful and release more radiation than others. Scientists estimate that a supernova would need to occur within about 50 light-years of Earth to have a significant impact on our planet. This distance is known as the kill zone. Within this kill zone, the intense radiation from the supernova could strip away Earth's protective ozone layer, leaving us vulnerable to harmful ultraviolet radiation from the sun. This would drastically alter our atmosphere. This radiation could have devastating consequences for life on Earth, potentially leading to mass extinctions. The loss of the ozone layer would expose all living organisms to increased levels of UV radiation. The impact on our technology would be equally severe, disrupting communications and potentially causing widespread power outages. Satellites and other space-based technologies would be particularly vulnerable to the radiation.